Hi everyone, in this video we'll demonstrate how Specmatic helps you leverage your existing Avro Schema files to contract test asynchronous applications. We'll achieve this by directly referring to these Avro schemas within an async API specification, using it as the definitive API contract for your event-driven architecture. Let's understand the architecture of our sample application. We have a checkout service, an order service, a Kafka broker, and an Avro schema registry. The checkout service serializes a message using the new order schema from the registry and publishes it on the new orders topic, which is then consumed by the order service. The order service deserializes the message using the same schema and publishes a reply message on the WIP orders topic. This message is again serialized using the WIP order schema from the registry. The checkout service consumes this message and does further processing. As you can see, this is a classic request reply pattern. This asynchronous interaction is captured in an async API specification. The async API specification also captures the schemas of the messages involved. But the good part is, it refers to the existing schemas from the Avro registry using the schema URL as the reference. So, no need to redefine the schemas. You might be wondering, if I have Avro already, why do I need this async API spec? The thing is, Avro primarily captures the payload schema. It is also good enough to take care of schema versioning and compatibility using tools like Confluent CLI. But it does not capture the entire contract of your asynchronous interactions. The details like specific topic names, the full EDA patterns, etc. are not captured by Avro schemas. This is precisely where async API spec helps bridge the gap by defining the entire contract of the async interactions along with the message schema definitions. Let's quickly have a look at this async spec. In our case, the order service is the system under test, and hence the spec is written from its perspective. As we can see, we have necessary topics defined here. And if I scroll down, this is how the schemas are referenced by using a schema URL. You can note that the schema registry URL is a placeholder over here. This is because it varies in different environments. Let's also take a look at the operations. This is the placeholder operation where it is specified that on reception of a message on the new orders topic, a reply message is sent on the WIP orders topic. Let's now dive into how Specmatic helps test whether the order service is adhering to this contract or not. In test mode, Specmatic Kafka replaces the checkout service and acts as the client. It reads the async API spec and automatically generates tests for the order service. Since the spec explicitly includes the Avro schema registry URL, Specmatic Kafka can seamlessly fetch the necessary Avro schemas directly from the registry for message serialization and deserialization. Here is how it works. Specmatic Kafka sends a message to the request topic and then waits for a response on the reply topic. While doing so, it uses the schemas from the registry for both serialization and deserialization. Specmatic then verifies if the reply message was delivered, validates any messages sent in the response per schema validity, and ascertains that all messages were sent or received within the stipulated timeouts. As we are aware about the test setup, let's run the tests. This is the test that we have written using Specmatic Kafka. We are also using compose container to bring up the schema registry during setup and bring it down during teardown. Let's run the tests. You can also notice that there are only setup and teardown methods and no actual tests. The tests that will run are actually generated by Specmatic. As the tests run, let's look at the containers being brought up by the test. We can see that schema registry is running here. This is what the contract test will contact with to fetch the necessary schemas. Contract test is able to communicate with the schema registry using properties being set here, which includes schema registry URL, schema registry kind, and available servers. We can see we got two passing tests here. Let me open the HTML report generated by Specmatic. We can see two passing tests here. Upon receiving a message on new orders topic, should send a message on WIP orders topic. Generated using two examples, place MacBook order and place iPhone order. For place MacBook order, this is the request message and this is the reply message. Similarly, for place iPhone order, there is request and reply messages. These messages are serialized and deserialized successfully by Specmatic Kafka using the Avro schemas from the schema registry. Thus, Specmatic Kafka tested the contract defined the async API spec, keeping the order service as the system under test. and using the Avro schemas from the schema registry. Now, to truly validate the power of contract testing, let's intentionally break our contract. I'll simply now start publishing the reply message on a different topic. Let's run the tests with this change in place. As expected, the tests have wait. And if we look at the reason, the tests were waiting for a message on the whip orders topic but failed with a timeout exception. This demonstrates how Specmatic Kafka can catch contract violations early in the development cycle, ensuring that your services adhere to the defined contract and communicate correctly. To summarize, Specmatic Kafka makes it easy to contract test asynchronous systems that use Avro Schema Registry. It automatically detects schema mismatches, validates complete contract compliance, and ensures robust, reliable service communication. Thanks for watching.